recursively refer to each other, you could get sort of infinite definition. Or if there is something like a fractal where maybe you can define things, but if you
Oh
think
yeah,
about them in
yeah.
a different way, like they can be infinitely definable, but in a way that doesn't just kind of continue with infinite scale, or like is something that you can describe as a discrete kind of limited whole, like the Sierpinski triangle. You know, you can talk about the exact amount of volume that fractals take up, or the exact amount of space and distance, length, and stuff, even though they're infinite because they're finite in size or scale. Well, in some sense.
Uh-huh.
So I don't know. Maybe there's just a different conception of definition that you could do more with. So, like, if you imagine if you take a slinky and a really long slinky and you put the ends together, at a distance, it would look like a circle. If you zoom in a little bit more and you can only see the edge, it might look like a, a straight or slightly curved line. And if you zoom in a little bit more, you'll see it's actually a loop of wire. So like it can look different at different scales. This looks like the Mandelbrot set, which is um, also different at different scales and just keeps going in infinite detail. So the whole thing takes up a fairly small amount of space on a graph. It takes like maybe a 1 by 2 tall grid. So yeah, they kind of bridge ideas of infinite and finite in a very interesting way. Like where things are like